Hello, everyone. Let's get started on section 4. This is on what's generally referred to as measures of central tendency and measure of dispersion. So, sometimes called measures of center, that kind of thing. And this is probably something you've seen before. I would say everybody has talked about the average and that kind of concept. Now we will define it more carefully, name it what we're supposed to name it, and talk about a couple different things. This section will take a couple videos to get through as we go, as we define things. Again, you have a couple sources to look at. You have Mendenhall in chapter 2, OpenStax as well. And you can use any other reference, but again, when you do your exams and quizzes, it needs to be this content as I'm describing it. And also to remind you, the homework questions will be most of the quizzes. So you'll have it out and you will answer it based off those. And then you'll upload those sections as well for part of the quiz. Okay, let's get started. So we want to talk about mean, median, mode. If you've had any sort of math before, you probably talked about this, but I want to define it again, talk about some nuances that we'll be going over. So first, let's talk about the mean or the average. So there are two different types, I wouldn't say two different types, two different ways to describe the mean. So mean or average is, both of these are basically thought of as like the middle of a data set. So we look at a bunch of data. The simplest way to just think of this that you're used to probably is your exam scores or grades or something. And you look at the average. What was the average on the exam? I didn't even know this until last year or last spring, that it automatically gives you the average for the exams. When you look up in Canvas, I didn't know that. I can see it if I calculate it, but I don't see it just automatically. Anyway, let's get started. So this is sometimes called the arithmetic mean. Arithmetic mean. Okay, and that's what we're defining first. So here's the definition. So if x1, x2, x3, etc., all the way to x sub n. So there are n data points, n measurements. So if that are n variables, or I'll say data points. That's just kind of how I think of the way we want to say it all the time. From a population. So we're going to first describe this in terms of the entire population, and that has one symbol. And then we're going to describe this in terms of the sample, which has another symbol. So a data set from a population. So yeah, from a population, then mu, it's the Greek letter mu, is the population mean. So sometimes we will be able to know the entire population. Most of the time, I would say, in experiments and research, you don't know the entire population. You are only doing a sample of it. That distinction will be important, especially for what we call standard deviation for later. But for now, so this is like the actual mean of the population or average of the population, and it's defined with mu, and where mu, so it's Greek letter mu. So mu is defined to be basically the sum of all of those to x sub n divided by however many data points you have, which is n. So you probably know that. You add up all the numbers, divide by the number of numbers. So it's the sum over all the x sub i's divided by n. And I will ask you to do this calculation by hand for a little while, for this quiz. And probably a couple examples or questions in the midterm. But after that, you'll be using a calculator and stuff. Okay, so you sum up all the numbers. So you basically, another way of saying it is mu is the sum as I goes from 1 to n of x sub I, and then you divide by n, however many there are. So those, of course, have to match right there. Okay, so that's considered population mean. The sample mean is denoted x bar. So x bar is the same calculation, but it's a sample of the entire population or entire data set. So if you are looking at the population of Chaffey College students, and often what they do is they just sample classes. They take random classes and sample that entire class. And then within that class is a subset of that class, because you can't get everybody in that same class. So there's, that's where education research is often very, let's just say it's not really well defined. If you get a large number in a large sample, then the responses start to make more sense, and that's where it's very elusive. I'm skeptical sometimes with some of the research we see in education, and I have done research in education. That's my doctorate degree is education. So I kind of can see what happens sometimes. Anyway, so X bar is the same definition. I'm not even going to rewrite it. It's the sample instead of the entire population. All right, so let's do a calculation. Oh, give me 1 second here. So we'll just make one up. All right, so for example, let's just call it example. This could be population or sample, it doesn't matter. So let's suppose you have, I'll just think of exam scores. So you have 45, 81, 72, 90, 75, 68. Okay, so suppose those were the exam scores. So first of all, you want to indicate your N. Sometimes it's capital N, sometimes it's lowercase n, depending on the book, depending on the instructor. So your N, and that's always something you're going to be asking. You're going to be, what's the N? What's the size of this sample? What's the size of the population? Who are we talking about? Those are things you want to be asking. Well, 1, 2, 3, 4, 5, 6. Okay, so your N is 6. Not a very big sample, not a very big population, but it gives you the idea. So you want to add them all up. Okay, so you would say the mean, because we'll call this the entire universe is that. So the entire sample is that. You add them all up. 45 plus 81 plus 72 plus 90 plus 75 plus 68, and you divide by 6 and you say equals. So do that calculation. I will do it real quick too. This will be real time. 45 plus 81 plus 72 plus 90 plus 75 plus 68. I get 431. Oh, and sometimes you want to guess what it might be. So if you guessed what this is, it looks like the average will be in the 70s, I'm guessing. Divided by 6. Oh, look, 71.8. So it's equal to 71.8. So the average is 71.8. So what does that tell me about this data set? Well, it can tell you something, but it often doesn't tell you a lot. So if I said the average was 71, that sounds kind of low. I mean, it's passing. It's, 70 it would be a C minus technically, but we can't give C minuses, so it's a C. You pass the class, but if you look at the scores, actually, most of them are higher than that. 1, 2, 3, 4 exam scores are actually higher. Not quite this one, but 1, 2, 3 of the exam scores are higher. So that would be not really an accurate way to describe this data set. It's skewed in some ways, and you see an outlier. So things that are kind of away from the mean, those are called outliers. So which data set is the biggest outlier? Yes, well, obviously it's this 45. Okay, and often in classes, and it's changed over COVID's, lockdowns and stuff. But back when I was, regular class situations, and we had prerequisites and things like that, what I would often see is actually what we call a polarized set of data. You see basically a bunch of people passing and a bunch of people well below the mean, which is totally unexpected if you look at how data should cluster. Anyway, we'll get to that later, but that just kind of beside the point. Okay, so that's mean. So you can, depending on whether this is a sample or population, you call it mu or X bar. And we will make that distinction. It's not a real critical distinction right now, but it's something you need to be aware of as we move forward. Okay, let's continue. So that's mean. You will practice some of those in homework as we go. Let's talk about median. Sometimes the median is the better indicator of central tendency. When you look up the the median is not as susceptible to outliers like that 45. The median is the central data point. So you add up all the numbers, it's the middle one. And when you look at income, like often one of the things you see a lot is the median income of a state, median income of a city, and the median income is what is the more established, real central tendency of income. And the reason is those outliers can skew the data. You have a couple millionaires, billionaires in a city, well, that's going to completely skew the data. You may not have anybody within that range. So the median is really the better indicator in that case, not always. So these are the things we start talking about. Okay, so the next definition is the median. The median of a variable or data point is the value that lies in the middle of the data, in the middle of the data, when arranged in ascending or descending order. It's basically, it's an ordered set is the way we would say that. Excuse me. So it's ordered from left to right usually, but this says ascending or descending. It doesn't matter whether you do that, but usually you go left to right, so you go less to greater. Okay, and we'll use M for the median. I'm not sure that's standard for everything, but okay. So then, if there's an odd number of data points, then middle. If even, you average the two. If even, you average the two middle. Okay. So give me a second here. Let's see if I could find one that I wanted to do. Okay, so I wanted to give you a different looking one. Let's see if I could find it. I'm not sure where all that work went. Oh, and I don't do a whole lot of editing on these things. I just have to crank these things out. I mean, there's really no getting around it. There's a lot of work that has to be done. In the past, I didn't do the videos, but I've learned how to do the videos pretty quickly, although it still takes more time to mesh them together. Anyway, doesn't matter. So let's see what I got for you. Where did it go? I have, excuse me. Let's see. I might end up cutting this part out, but I don't know. We'll just roll with it. You're okay with that, I hope. Okay, let's look at this one. So suppose you have this, let's do mean and median. So let's calculate mean, median. You'll see why this is a little different. 4, 5, 7, 8, 8, 9, 10, 10, 10, 12, and 58. So often what happens too when I see statistics and data presented like in our descriptive concepts, when you're like the chart I sent you, you always have to ask what the N was. And if it's not presented, it's not good research. You have to know what the size of the sample, the size of the population to make an inference about anything. And that's what I often see as an issue. So like this, sometimes if the data is small enough, you can interpret it without all this fancy stat stuff. It's when the data gets above what the brain can handle, then that's when you need to do all these statistical analysis concepts. And when it's very critical of the outcome, like in medicine, and we'll get to this later, but the medicine, what you expect, or what you need to see, is a much smaller margin of error for medicine, because the results could be more catastrophic. Not so much in education, and I'll talk about that. It's called the p-value. The p-value in education, it's like I think it's like 5% is we'll get into that later. But in medicine, it's like 0.01% or like 1%. Like, you have to, and don't quote me on any of that stuff. but do you see the difference? Like, in education, if you make choices based off 5% versus 0.01%, that's a big difference. So on this data set, we can see that that's an outlier. That's going to skew the result big time right there. But if you look at the median, it'll give you more of what the central tendency is. So this is an ordered set, isn't it? Ordered data, 4, 5, 7, 8. Yeah, it's order. From left to right, it's order. It's ascending. It can be descending. That's not really the critical thing. It's just we're used to going left to right when you're doing your number line, which is nice because, when you read things in different languages, some languages go right to left. Some languages, like English, left to right. Some, of course, go down. But in mathematics, there's a universal, at least not worldwide, agreement on just about everything. So left to right is ascending. So that's kind of nice about math. It is really the great equalizer. And that's what I love about it. One of the things I love about it. So left to right, let's look at central tendency. So you count the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is odd. So your n is 11. We'll look at the mean, and let's just pretend this is a sample this time. So we'll call it x bar. We add them all up. So you do the sum, and I'm not going to write it out. We'll just do it over 11. Okay, let's find the average. So let's get out our calculators. For a while, you just need 4 function calculators. For the next week, 4 function calculators. Now, I'm trying to do this a generic. I am doing this as we go through this course, but I want to keep this more generic for all my length of classes. So I apologize for those in the future if I say stuff like that. So let's add those all up. 4 plus 5 plus 7 plus 8 plus 8 plus 9 plus 10 plus 10 plus 10 plus 12 plus 58. I get 141. I really hope these are right, otherwise I have to redo it. Let's do that again just in case. Many of these I haven't done ahead of time. Some of them I've taught stat a number of times. As I think I mentioned, I mostly teach calculus and above in the last 10 years, and a ton of algebra over my career, but not as much stat. It's very applicable. Stat is very applicable for everything that you do. Just didn't end up doing it. So let's do it again. 4 plus 5 plus 7 plus 8 plus 8 plus 9 plus 10 plus 10 plus 10 plus 12 plus 58. 141. Okay. I was pretty confident I had it right, but I just wanted to show you sometimes you want to double check. Okay, then we divide by 11, and I get 12.8. So look at that difference in that outlier. That outlier is 58. I still get 12.8. Look at that. That is above every single data point because of that 58. So let's look at the median and see if that gives a better indication of this data. So what you do is you just count 11, And then, so then you just take the middle one. So the middle one, you just divide by 2. Well, it's like you count 5. It's like 5 on either side, right? And then the middle one's 11, right? So you just count 5. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So I could do it like this, because I have cool highlighters. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so we can see that the middle is 9. So the median really is like the middle. It's the middle data point. Okay, so the median is 9. And look at how different that is, the 9 and the 12, almost 13. So 9 is really a better indicator of what that data set is. And it all depends on the information and how you analyze it. Okay, so the median is 9. Okay, so that's the concept of median. All right, we are almost, I try to keep these below 30 minutes. We're almost 26. Okay, we will stop there and move on to the next concepts. Let's just do a little recap again. So we've really just done A and B. We'll do mode, variance, and standard deviation, and range next. Probably 2 more videos for this. And we'll see you in the next one.